What's going on, guys? Going to make another video today. This one's just specifically going to be focused on inverters and the differences in inverters. Basically the pure sine wave versus modified sine wave. One of the things I want to point out right off the bat, a modified sine wave is basically just those inexpensive inverters you see at Harbor Freight. They're like $160, $200, and they put out like 85,000 watts. Those are great for power tools, lights, anything along that category. Something that doesn't have a computer chip in it. So running your floor fans, your regular fans, your Sawzall, circular saws, those will run great for you. And they put out tons of power for really little money. Where you have to draw the line, though, is if you're planning on using something a little more technologically advanced. So you want to run your freezer off of it. You want to run your computer, your TV, microwave, whatever you're choosing to do, you have to do a pure sine wave inverter. And the one thing you'll always notice is they always say pure sine wave inverter down the side. So just some things to look at. Like this little fellow I built, a couple weeks ago or a month ago. It's just got a little 400 watt inverter on it. It peaks out at 800 watts. Paid like $100 for it. It'll work great for powering this thing up. The thing you'll notice, though, anytime you're using it on something, especially sensitive electronics, it produces a buzzing sound. I'll probably actually show you that here in just a few minutes. Now, another thing to consider or think about when you're buying these things is if it sounds too good to be true, it probably is. So this is a 48 volt, 2000 watt pure sine wave inverter I bought on Amazon for like $125. Now I've used it. I've actually had it running these two freezers that I'm standing next to off of a 48 volt system. But the most I've ever actually drawn on it's probably been about, I don't know, 1200 watts. And it handled that just fine. It'll normally drop back down to only around 180 to 200 watts with both refrigerators running at the same time. Now, I just want to point out, these are the wires that actually came with this inverter. So, I mean, you can tell they're very low gauge. They're only about a 12 gauge. So if you want to tell me that you can run 2000 watts at a full draw on 12 gauge wire, I'm going to go ahead and tell you you're probably delusional. Another thing to look at, here's a 2000 watt inverter next to a 2000 watt inverter. So most likely it can't put out that full power, but it does work. So, I mean, if your budget is, limited, well, it's not a bad thing to start with. You can always look to upgrade later. Pure sine wave is always going to do more for you. There's more use cases than the modified sine. To kind of just make a quick explanation of the difference between modified and pure sine, you tend to have this little diagram on the top and it shows a nice smooth wave flowing. Now a modified sine wave tends to be a little bit more blocky, where it's just hard, sharp edges. I mean, you think about anything, if you're trying to race, you want a nice smooth flow. You don't want up, down, left turn, right turn, left turn, right turn, left turn, right turn, because it slows you down in those turns, or it puts resistance. So the pure sine is more like, or is actually sometimes better than the power that comes out of your wall from the grid. So just something to keep in mind. Again, you can run stuff on a modifying sine wave like your TV, but it's going to make that buzzing sound. The other issue you're going to run into is it's going to burn it out eventually. It'll definitely kill the longevity of your equipment, especially like a refrigerator or freezer. And if you're having to run your freezer off of something like this, the last thing you want to do is break it too. So if you go on Amazon, you can find the modified sine wave ones for around $169 to $200 for a 3000 watt. Now, if you look at like this Renogy, you go 3000 watt on that, it's roughly around $260 to $360. So I mean, it's worth the money to go with a better quality, because most likely if you run it down or really load it down, you're not going to damage it. Whereas in the $139 special, you'll probably cook it. So if you're running it easy, you're running it light, you've got a pretty good chance of getting a good life out of this thing. But I mean, if you're going to spend the money, cry once. All right, let's do a quick little test for you. I do want to show you the difference between this little 400 watt running this fan versus the 2000 watt running it. Obviously running a 2000 watt is better, because you think about it, if you put a 4-cylinder in a big old SUV versus a V8 in the same SUV, one has to work way harder to do the same job. So let me fire it up just so you can hear it. You might be able to hear the buzz. Actually, I will start with the pure sine wave first. So you can hear it doesn't have any trouble firing it up. It spools up pretty quick, works really well. Obviously does exactly what it's supposed to, and that's why we, spent the money and the time on it. We'll fire on the little guy. This little fella has a fan that runs all the time, which, I mean, in the electricity world, it's drawing current, so you're wasting your battery. So always try to find one that only runs, when it's under load. Like this thing has never turned on even when I was running a circular saw on it. So you hear it struggling. That's one. So as you can see, it's doing the work. It's not having a problem firing it up, but you do hear that intermittent buzzing sound in it. Now, it may be a little annoying in this fan, but it's not going to hurt the fan. But you start putting it on sensitive electronics, it can hurt it, absolutely. And on another thing, actually, I'll show you a quick draw test on this fan, just so you can see what it's actually pulling when it loads up. Sorry, I know I have the finest quality of camera footage, but we'll fire it up. 172 watts max on that. That was one. 144 on 2. 157 on 3. So we're only pulling 157 watts, and you heard how much it was loading down on this little 400 watt inverter. And I mean, it's been a decent inverter. I actually had this installed in my car probably 15-20 years ago, and I just kept an extension cord and a drop light because I could hook it up and I had power anywhere I went with my car. So it's nice to have. Cars have them built in now, but there's still a lot less wattage in this. I think most of those are normally around like 1 to 200 watts. So you can easily add something like this. You can add a modified sine wave 2000 watt inverter to your car, but you're going to need a lot of cabling for it. So it tends to get a little expensive. But something like this is always a good little thing to have, and they're not expensive. But this is always a great case for you. 48 volt versus 12 volt is always a benefit, because if you think about your voltage stepping, if you have a 12 volt battery and you're trying to step it up to 110 volts, it's a much bigger jump than if you're at 48 volts in batteries and then stepping it up to 110 volts. So your inverter doesn't have to work as hard. You can actually get away with smaller cabling. I mean, obviously this is still a joke, but I mean, if you're having to use 8 gauge instead of 0 or 1 gauge, or 4 gauge instead of 0 and 2 gauge, your cost just, it gets better, much better, because instead of running something like this cabling, you got to run this big old fat meaty boy. So just some things to consider, something to look at. I definitely like this Renogy. I've loaded this thing up. I've tried to beat it up and abuse it far too many times already. And I'm working my way up to getting this thing hooked up so I can really abuse some things. But, you know, this is basically this on steroids. It's already got in the solar charge controller built in. It's already got the inverter set up. It does not have the batteries, but that's what those are going to be for. And it runs everything. Plus, it'll take up to 21 kilowatts of solar input. So that's pretty awesome. So basically, I'm just looking at what's your scale up, what do you need? Again, you can run this little setup right here. You can get, you know, a 1 or 2,000 watt similar to this to run off of that. But you tend to need more batteries. Even if you buy a pre-made one, they normally only have a battery about the same size as this one in it. So just things to look at. If you got any questions, put them in the bottom. Hopefully I'm not rambling too much, but I feel like I am. Anyway, talk to you later, guys.